A random variable capital X takes the continuous values, then the random variable is said to be continuous random variable. The function f of x is said to be a density probability density function if it is satisfies the conditions. One is f of x greater than 0 or minus infinity is less than x less than infinity. And the second factor is minus infinity to plus infinity integration f of x dx is equals to 1. So the entire area bounded by the curve f of x together with x axis equals to 1. Then the function f of x is said to be probability density function. Now we'll see some problems on continuous random variable. So first one, a continuous random variable capital X has the probability density function f of x equals to 3x square. 0 is less than or equal to x less than or equal to 1. Find A such that probability of capital X less than or equal to A is equal to probability of x greater than A. Now, since probability of x less than or equal to A equal to probability of x greater than A such that both probabilities are equal to be 1 by 2. So, therefore, probability of x less than or equal to A equals to 1 by 2. So, integration 0 to A f of x dx by the definition of the probability density function p of x less than or equals to a is equals to 1 by 2. So integration 0 to a f of x dx equals to 1 by 2. So 0 to small a, what is the probability density function is 3x square dx is equals to 1 by 2. So a cube equals to 1 by 2, therefore a equals to 1 by 2 whole to the power of 1 by 2. Next. A random variable capital X has a probability density function f of x given by f of x equals to cx into e power minus x if x greater than 0, 0 if x less than or equal to 0. Find the values of c and the cumulative density function. Now we have the f of x is the probability density function, then integration minus infinity to plus infinity f of x dx equals to 1. So, but his function is defined for x greater than 0 because x less than or equal to 0, the probability density function is 0 is equals to nothing but integration 0 to infinity c x into e power minus x dx equals to 1. X is the constant, then x into minus e power minus x minus e power minus x from integration 0 to infinity equals to 1. Implies that we will get c equals to 1. Now my function is f density function is f of x equals to x into e power minus x when x greater than 0, 0 x less than or equals to 0. How to find what is the cumulative distribution function of x? By the definition, f of x equals to integration 0 to x f of x dx. So 0 to x into e power minus x dx. So if I substitute this one, then minus x into e power minus x minus e power minus x. Some integration 0 to x. So 1 minus of 1 plus x e power minus x is the probability distribution function, or you can say cumulative distribution. Now we'll move to the next problem. A continuous random variable capital X that can assume any value between x equals to 2 and x equals to 5 has a probability density function given by f of x equals to k into 1 plus x. Then find the probability x less than 4. Now clearly given that small f of x equals to k into 1 plus x and between 2 less than x less than 0 otherwise. That means the entire probability density function there is just 2 less than x less than 5 and 0 in remainder. Now we have the definition of the probability density function minus infinity to plus infinity f of x dx equals to 1. So integration 2 to 5 k into 1 plus x dx equals to 1. So k into 1 plus x whole square by 2 from 2 to 5 equals to 1. Then k equals to 2 by 27. Now, probability density function becomes f of x equals to 2 by 27 into 1 plus x. Then 2 is less than x less than 5, 0 other. Now, how to find what is the probability x less than 4? So, 2 equals 2 by 27 into 2 to 4, 1 plus x. So, if I substitute these values, then the value is 16 by 27 is the answer. If a random variable capital X has the probability density function f of x equals to 1 by 2 into x plus 1, minus 1 is less than x less than 1, 0 otherwise, then find the mean and variance of the x. Now, to find the formula of the mean is integration minus infinity to plus infinity x into f of x dx. There is a formula to find the mean of the continuous random variable capital X. For this one, for the given formula, for the given function, for the given function f of x, mean equals to minus 1 to 1 integration x into f of x dx. So is equals to 1 by 2 into x plus 1 integration minus 1 to plus 1 dx. So is equals to 1 by 2 into integration minus 1 to plus 1 x plus x dx. So 1 by 2 into x cubed by 3 plus x squared by 2 minus 1 to plus 1 is equals to 1. Now, what is the expectation of x square? So expectation of x square equals to integration minus 1 to plus 1 x square into f of x dx. So is equals to 1 by 2 into x cube plus x square dx. So if I solve this one, 1 by 3 is the answer. Now to find the variance, the formula is expectation of x square minus expectation of x whole square. Otherwise, in other words, I can say expectation of x square minus mu square. So mu expectation of x square value I got 1 by 3 minus mu is I got 1 by 3. So 1 by 3 minus 1 by 9 is what is the 2 by 9 is what answer for the variance of the random. Now, I will move to the next problem. It has a probability density function f of x equal to k into e power minus 3x for x greater than 0, 0 otherwise. Find k and what is the probability 0.5 less than or equal to x less than or equal to 1 and the mean of the x. Now we have definition of the probability density function minus infinity to plus infinity f of x dx equals to 1. So integration 0 to infinity probability density function is a k into e power minus 3x for x greater than 0. So integration 0 to infinity k into e power minus 3x dx equals to 1. So if I substitute these values, then I'll get k equal to 3. That is the probability density function is f of x equal to 3 into e power minus 3x when x greater than 0, 0 otherwise. Now, how to find what is the probability of 0 point less than or equal to x less than or equal to 1? So, integration 0.5 to 1 f of x dx. 3 times of 0.5, 1 to integral 0.5 to 1 e power minus 3x dx. So, get the answer e power minus 1.5 minus e power minus 3. Now, we have to find what is the mean of the x. By the definition of the mean, mu equal to expectation of x equals to integration 0 to infinity x into f of x dx, because the function f of x is defined only for x greater than 0 and the remaining interval the function is 0. So expectation of x equals to integration 0 to infinity x into f of x dx is equal to 3 into integration 0 to infinity x into e power minus 3x. So substitute this one, then I'll get the mean is 1 by 3. Hence, the mean of the x or expectation of x equals to 1. I will move to the next problem. A continuous random variable capital X has the probability density function. If f of x equals to 2x for 0 is less than x less than 1, 0 otherwise. We have to find what is the probability of x less than 1 by 2. Probability of 1 by 4 is less than x less than 1 by 2. Probability of x greater than 3 by 4 by x is greater than 1 by 2. Or you can say 1 by 2 is less than 3x by 4 is less than x. Now, x less than 1 by 2. So, integration 0 to 1 by 2 f of x dx is equals to integration 0 to 1 by 2 2x dx. So, 2 into x squared by 2. So, that will answer is 1 by 2. Now, we have to find what is the probability of 1 by 4 is less than x less than 1 by 2. So, integration 1 by 4 to 1 by 2 f of x dx. I'll substitute these values and I'll get the 3. Now, the third problem is probability of x greater than 3 by 4 is 3 by 4 into x greater than 1 by 2. Simply, it's the probability of x greater than 3 by 4 intersection x greater than 1 by 2 by So probability of x greater than 1 by 2 is nothing but probability of x greater than 3 by 4 by probability of x greater than 1. What is the probability of x greater than 3 by 4 means 3 by 4 to integration 3 by 4 to 1 f of x dx is equals to integration 3 by 4 to 1 to x dx. So the answer is 7 by 16. Now we find what is the probability of x greater than 1 by 2 is equals to integration 1 by 2 to 1 f of x dx. So the answer is 3 by 4. Now I want to find what is probability of x greater than 3 by 4 into x is greater than 1 by 2. So is equals to nothing but 7 by 16 by 3 by 4. Answer is 7 by 4. So I will move to the next problem. Let random variable capital X as the probability density function integration 1 by 2 into f of x equals 1 by 2 into e power x by 2 x greater than 0. Now find the movement generating function, mean and the variance. Now the movement generating function mx of t equals to expectation of e power px, so minus infinity to plus infinity e power px f of x is equals to integration 0 to infinity e power px 1 by 2 e power x by 2. Then minus x by 2 then is equals to this. So substitute the values. Then I will get the function is equals to 1 by 1 minus 2t if t less than 1. So the expectation of the x equals to d by dt are mx of t is equals to 2 by 1 minus 2 square and 0 at the t equal to 0 is equals to 2. Now expectation of x square equals to double derivative of mx of t at t equals to 0, then 8 by 1 minus 2 whole cube at t equals to 0 is 8. So variance of the x equal to expectation of x square minus expectation of x whole square. So 8 minus 4 equals to 2. So these are the problems on continuous random variable.